Hello, we're group number 15 and we're going to talk about welding. My name is Kamal Alonso and my teammates are Atria.
I'm Victor Consuegra.
Welding is a typical fabrication process in which the base metal is heated to the point of melting in addition to a filter material being added to the joint. This process is known as a fusion welding, which is at higher temperature than brazing and soldering. Materials that can be welded. The weldability is a material's ability to be welded. Materials that can be welded are metals and thermoplastics. It is important to note that some materials are easier to weld than others. A chart like this helps select the welding process which is used. Types of welding. The first one is shielded metal arc welding, also known as stick welding. Then there is the gas tungsten arc welding, gas metal arc welding, flux-cored arc welding, submerged arc welding, electroslag welding, laser beam welding, magnetic pulse welding, and friction stir welding. First, we're going to talk about the shielded metal arc welding. This one uses an electrode that is coated in flux in order to pass a current from the power supply to the metals that will be joined. It is primarily used to weld iron and steel. It also can be used on aluminum, nickel, and copper alloys. The advantages and disadvantages. The advantages are that these are cheapest material. The equipment setup is simple. Process is cost effective, good for either indoor or outdoor welding, and not as dangerous as other methods. The disadvantages are that it takes a while to master, not a great welding thin materials, and requires electricity. Now we're going to talk about gas tungsten arc welding, also known as TIG, which means tungsten inert gas. It uses a non-consumable tungsten electrode that is surrounded by an inert gas. A separate filled material is also used to produce the weld on the pool. Advantages and disadvantages. The advantages are there are great control over the weld, stronger welds, high quality welds. It's also used to thin section of stainless steel and non-ferrous materials. The disadvantages are that it's more complex, is most difficult to master, and is significantly slower than other welding techniques.
Gas metal arc welding, also known as MIG, meaning metal inner gas, uses a consumable wire electrode that is surrounded by an inner gas and originally developed for welding aluminum and other non-ferrous materials. Types of MIG welding are metal inner gas, metal in gas, gasless MIG welding, wire feed welder, gas metal arc welding, stainless steel MIG, and aluminum MIG. Advantages and disadvantages. Some of the advantages are great versatility, much quicker than other processes, ability to adapt into robotic automation, simple to learn, high productivity, clean and efficient. And disadvantages, we have not great to use outdoors, high cost, fast cooling rate, metal preparation time, and unsuitable for thick metals. Flux-cored arc welding. Mainly it uses a continually fed consumable electrode that contains flux. Flux creates the liquid and gaseous protections, originally developed as an improvement for SMAW welding. Advantages are no shielding gas needed, low skill required, less per cleaning of metal. Disadvantages are porosity, holes in welded material, high cost, filler material, high amount of dangerous fumes, post-weld cleaning. Submerged arc welding, also known as SAW, an arc welding technique in which the weld area and arc are submerged under beta flux, usually an automatic system. Advantages are deep weld penetration, high-speed welding, and minimal welding fumes. Disadvantages of this type is limited to ferrous metals and normally limited to long straight seams.
Okay, now I'm gonna talk about laser beam welding, which means that two or more pieces of metal are gonna join together by using a laser beam. The application of this one is gonna be used in electronics, used in medical equipment, and also used in transmission components. These have some advantages and disadvantages. One of the advantages is that similar and dissimilar materials can be joined together. It has great precision, and heat affect the zone is very small. And disadvantages is that a slow welding speeds, that's not very good. The higher equipment costs and the higher cooling speeds can cause the cracks on the welding parts. Now I'm gonna talk about the magnetic pulse welding, which is the newest manufacturing processes in the welding field, which is basically a welding process where it uses magnetic forces to weld two pieces together. This welding process, as I said, is the newest one, so they haven't found the disadvantages. So one of the advantages are that it's manual or automated process. There's low energy consumption on this. There's a fast charging time, so it's basically like 5 minutes in order to charge the machine, which is going to use to the welding process. No heat effect zone because there's no use a lot of heat, and no smoke or sparks. This one is the last welding process that we're going to explain, is the friction stir process, which is basically there is a third part of the process which is involved welding two pieces together by friction. It's a machine like revolving like in high speed and welding the pieces together. It has advantages and disadvantages as well as the other one. One of the advantages is that a good mechanical properties, it's going to be good welded, improved safety, easily automated, it doesn't need to have a person to have to do it, and low environmental impact. The disadvantages is that it's an exit hole where the machine is going out of the two pieces welded, so it's going to be a mark of it, and it's a heavy duty clamping required. So basically what this means is it needs very strong machine to hold the two pieces that are going to be welded. Here we can see how there's the two pieces of metal. This one is the first one, this one is the second one, and this one is the machine I was talking about. It's going around making RPMs and until the two pieces melt and weld together. On this slide I'm going to show you our proposed design. This is the conceptual design of a laser beam welding machine. The difference from this one and the one we see on the streets right now is that this one has the powder and the laser on the same machine, on the same head of the machine. And on this slide right here, where I'm showing you a cross-sectional view of our conceptual design, which is basically to show you where the laser goes, where the powder is coming from, where's the point that they're gonna go together in order to weld, and where is the shielding gas nozzle that is normally internal on a laser beam welding machine. As a conclusion, we can conclude that welding is basically put two parts of metal together. There exists too many types of welding machine. It depends on what you want or what you don't want, or how much money do you want to spend, or any advantage or disadvantage that you need.